Alright, so I'm doing my topic on physics of cars. I got my car out here in the desert. Alright, so the first thing I'm going to cover is going to be changing chemical energy into kinetic energy. So the first thing you do, you have a battery. The battery is based off of chemical energy, which is lead and acid. The chemical reaction. The chemical reaction makes 12 volts of power. That does is starts up your vehicle, and then from there you have what's called an alternator, which makes 14 volts of direct current using a very strong magnetic field. Alternator provides power for everything else on the vehicle, so when you go to hit the gas, you start moving, which creates kinetic energy. So the next little thing I'm going to cover is Faraday's Law. Faraday's Law is basically converting a little bit of power into lots of power. So how a car does this is, like I said earlier, 14 volts of direct current. That 14 volts goes through what's called a distributor right here. This distributor is based off of an ignition condenser. What that condenser does is it condenses down the 14 volts and makes it 40,000 volts. What that does is it goes through the spark plug wires down into the spark plugs and creates spark, which ignites the fuel. Alright, so another one of the aspects I'm going to talk about a little bit is friction. Alright, so in this case, like driving, friction is basically the resistance of an object, such as the road, and the rolling object with my tires. Without friction, you wouldn't be able to go anywhere. You wouldn't be able to drive, you wouldn't be able to move at all. When you would hit the gas, you just spin. Alright, so another else we want to talk about is going to be drag. Now, drag is basically the resistance on an object when it's moving. So in this case, like when you're driving, you're cutting through air with your vehicle. So the more air you cut through, the more drag there's going to be. So that relates to, if you're going faster, there's going to be more drag pushed up. Another important thing is surface area. If your car has very little surface area like mine does, mine's low to the ground and sloped down, so there's not much surface area for air to get caught on, versus say a big Dodge right there, that has a lot more drag. First of all, it's higher off the ground. Second of all, it has more surface area, frontal surface area, which is like the grill, the bumper, the hood. It's got more surface area on it. Therefore, wind and the air is pushing on it more when it's cutting through the air. So a bigger vehicle that has more surface area, frontal surface area, has to have more power to get to the same speed as, say, my car does, or something along the lines of a small fuel efficient car like a Honda Civic or a little Toyota or something like that. Drag is also very important when you're talking about fuel mileage. The more drag you're going to have on a vehicle, the less of the fuel mileage you're going to have, because you need more power to go a certain speed. So, like say this semi-truck right here, its torque ratio is rated at 1,000 foot-pounds of torque to that back wheel. My torque ratio is only 100 foot-pounds of torque to the wheels. But I can get up to speed using less power quicker than a semi-truck can, because I don't have as much surface area and as much drag to push on. A couple of things that relate to drag besides just air is actually dirt. Dirt creates a lot of drag too, because that builds up more surface area. It's millimeters. It's like 0.2 of a millimeter, but 0.2 of a millimeter, like say if you're going on a road trip, that's a lot. Turning over here, that's a lot, especially if you're driving long distances and your car is really dirty. So cleaner cars actually get better gas mileage than vehicles with dirty cars. It's not much. If you're going on a 60-mile road trip, taking the freeway, not really much of a road trip, but say for instance, my car's dirty, I only get 23.8 miles to the gallon on the freeway going 60 miles at 65 miles per hour. Now if I clean it, wax it, put a nice layer of wax on it and a clear coat, my fuel mileage increases to 25.4 miles to the gallon at 65 miles an hour for 60 miles. It's not much, but you know, every little bit counts, especially when talking about fuel mileage. Now, the type of drag that dirt creates is called parasitic drag.